Okay, as part of an experiment in the learning process, a mouse is put in a maze and rewarded with food every time it takes a right turn. If the mouse turns right and gets a goodie, the probability it turns right next time will go up 20%. If it turns left and doesn't get anything, the chance it'll turn left next time is decreased 20%. Assume there's an equal probability the first turn will be left or right. So the first time it turns left-right, it's a 50-50, but after that, it starts to figure out that it's right turns that we want and starts doing them more and more often. So right one and left one are the first turn is to the right and first turn is to the left. What is R2 given R1? This means a right on the second turn, given that there was a right on the first turn. So second turn is right, given that the first turn was right. Chance of that should be 70% if I'm reading this correctly. So this is saying, if we tell you for sure that the rat took a right at the first intersection, this is the chance that it'll take a right at the second intersection as well. And now they get us to crunch some numbers. The probability of each event. At first they say there's an equal probability that it'll go left or right, so the chance of it doing left or right on the first intersection is 0.5. At first the rat doesn't know what we want, so it's 50-50. The second turn is to the right, given that the first turn is to the right. They say if the mouse turns right, it gets a banana pellet or whatever. The chance of it turning right the next time goes up by 20%, so instead of 0.5 or 50%, it should now be 70% for the second turn. It went to the right, which it had a 50% chance to do, and then because it went right, we gave it the goodie of some kind, and now it's likely to take more right turns, hoping to get more goodies. I'm sorry, you couldn't see that. 50% to start with, an extra 20% because of the reinforcement of getting a reward, so now it should be up to 70%. And the second turn is to the left, given that the first turn is to the left. So it started out at 0.5, and they say up here, if the mouse turns left, the probability it'll turn left next time is decreased 20%. So in this case, it goes left, gets nothing. So 50% minus 20%. It only has a 30% chance of going left next time. It goes, okay, I went left, nothing good happened. Maybe I won't do that again. And put the probabilities in B into a tree diagram. Let's see how this works out. Rat starts out. It has a chance of going left, and it has a chance of going right. I'll put in the numbers in a moment. And then when it gets to the next intersection, it again will consider going left, or we'll consider going right. And it has the same choices after a right turn. Okay, when we started out, the rat had a 50-50 chance, 0.5 chance of doing either thing. If it goes left, they say, the chance of it going left again drops by 20%. So instead of 0.5, it's now only 0.3. That means the other 70% of the time, it should take a right turn. And after a right turn, basically the same thing happens. After a right turn, the chance of it doing another right turn goes up 20%, so it ends up at 0.7, and that means the chance of a left turn has to drop. If you're doing 70% right turns, that means you're doing 30% left turns. So now we can do each of these branches and figure out how probable it is. 0.5 times 0.3 is 0.15. 15% chance we have a very stubborn rat who goes left and left. 0.5 times 0.7 is a 0.35 or 35% chance that it goes left and then goes, okay, I'll go right this time. 0.5 times 0.3 is a 0.15, 15% chance that it takes a right, and then, despite having gotten a goodie here, it decides I'll try left this time. And 0.5 times 0.7 is a 0.35, 35% chance that it gets lucky and goes right the first time, gets rewarded, and decides to go right again. So now that we have that, the chance that they're both right is the 35 here, both left is the 15 here, and different is the two branches in the middle. We have left-right in this path and right-left in this path. You would add those up, so you get there's a 0.5 chance that it'll take two different turns.